Um, Hello everybody, and welcome back to uh the ninth video of the season four. It's pretty long playlist, but hopefully that's understandable. Layout sketching is a pretty tedious and kind of a lot of stuff in it. So, but today we'll be going over how to layout sketch an intake. And as per usual, my name is Anton. Raj still surprisingly did not change his name. Raj, say hi.
Yeah, I
And yeah, so we'll be doing a layout sketch of intaking of an intake mechanism for last year's. Well, Raj, what was your game called?
into the deep.
Into the Deep. Yeah, from Into the Deep season, the last season you could call it. And we'll just be intaking from the submersible, and then that'll be it for this video. And then we'll 3Dify quickly in the next video, so it shouldn't be too bad. Okay, so um, I did miss a couple of things in the drive base dock from last video. I forgot to include the extension limits for the robot and also the height limits, if there are any. So we're gonna go back into the game manual, FTC game manual. uh And then we go here. And so now we have to find the extension and height limits for this game. So, assuming design, game rules, robot construction. There you go. All right. Just keeping scrolling down. Um, there is a horizontal expansion limit. Okay. So, okay. So we're just gonna take a look at this one. So the horizontal size boundary is a 20-inch by 42-inch rectangled measure parallel to the tile floor. Okay. So horizontal size boundary. I'm trying to get this to what 20 inches. So okay, wait, hold up. So you guys have 42 inches from the side of extending, including the chassis.
Yeah.
Okay.
So I mean, what typically happens is like you'll extend forward as one way and extend up as the other, and the up extension is like basically not there. So maybe you may have to like flip around back, but it's typically like not outside the drive base area.
Okay. So it's just 42 inches on the side, basically. Um,
Yeah.
or should here, I'll just quickly draw it out. So for you guys, what we can do is we can quite literally just make a little box, kind of like this, and there is no. Is there a height limit?
No.
No height limit. Okay. And so it's 42 inches from including your chassis over here on both sides of the bot, which is pretty interesting. So Raj, do you think
Mhm.
we should leave some space out? You mentioned this a little bit ago, but like on the other side of the bot, or just go full 42 inches to the
Yeah, I
left?
think maybe you can leave a little bit of space.
Okay,
A little bit.
so what we'll do is we'll do like 10 inches, right? And then from here to a, I feel like this makes sense, right? This makes sense. This,
Mhm.
I feel like that makes sense. So 42
Yeah.
inches, and now we
Or
have
maybe make it a little bit smaller.
on the other side.
Actually,
Here, what will be?
yeah.
This is actually a great db um extra extend. We'll just make a variable for that, and we'll make it like. What do you think about 8 inches? Yeah,
Maybe five is good enough,
5 is
to
good
be
enough.
honest.
All right, let's do 5 then. There you go. Okay, so that's how 5 inches looks like. Okay, cool. And now we actually have to move the robot, the dry base, over to the submersible, right? As you would in real life, because you can't really do anything with it, right now. So let me. So right now it's fully constrained, so I can't move it closer to the submersible. So what I'll do is I will just forcibly make it air and find out what is constraining this thing from moving. So I think it's actually
Mhm.
just this one. There you go. Cool. So if you look at, I just hovered over this, right, and I just saw that this vertical construction line was coincident with the origin. So I just deleted the coincident constraint over here, and now it's able to move um, closer to the submersible. Okay, so we're gonna what we're gonna do for now is we're gonna pretend like we're fully up against the submersible, right? Feel like or Raj, what are your thoughts on this? Should we make the intake as if you guys were fully up against the submersible, or should we like make it so it's further away, like instead of tangent
You
to
can
it?
just
So it's like
you can add a little bit of clearance in between.
yeah. So we'll do
This shouldn't be a lot because we were basically touching it.
okay. So like maybe 1 inch.
Yeah, yeah,
All right,
that's good.
cool. Okay, so that is our boundary set up, the outer extension limit, and I would say that is it for the dry base. Now what I'll do is I'll just put all of this inside of a folder called dry base. Remember, use folders, they are really, really useful. Okay, so there you go. What I'll do for now is I will also get rid of all the planes and all of the kind of 3D sketches that we made. Because for now I'll only be working in the side view, and so I'll only need the side of the dry base. Okay, so we'll do intake layout, just like that. And now we can just kind of start making stuff. So today we're gonna try to make an intake that is uses Misumi slides and then has a roller claw at the end of it. Raj, do you want that whole thing to be rotatable, or will it just be you? Will you guys just turn the robot around? I'm not sure if
I think
turrets
you
are
can.
popular.
Wait. What did you mean by rotatable?
Like a turret.
Oh, just turn the robot around. Or actually, the outtake should ideally be on the back. But we can just do the intake for now.
I wonder if I. Yes. Oh, this is the outtake on the back. Ooh. Um. Yeah. So we're currently back up against everything, but that actually should be pretty quick change. This is why you want everything to be um, changeable when you're making a sketch. Because now what you can do is, if I figure out how I did this, we will, I'll hover over this point and I'll get rid of, so I'm assuming this rectangle, center point rectangle is coincident with the center of this circle. So I have to find that constraint somewhere. And then I'll have to change it. Man, this is pain. I should have made a submersible on the other side. Yeah, so this is why making sure your dry base is facing the correct way is important. Because I honestly just yellowed this without thinking prior to making my field elements. Because in FRC it's a square dry base, usually maybe rectangular, but it's like mirrored across. Here it's not, but Raj, is it fine for now if we make everything on the back?
Yeah, I think that should be okay. Like, we're not actually making the robot right now, so
Yeah.
it's okay.
So just make sure you layout sketch your robot the correct way, or make it face the correct way. Um, and then this actually might require you to make two different layout sketches for the dry base. So one where it's facing backwards and one where it's facing forwards, depending on what you decide for that year. But um, Just depends. Okay, so intake. We want to have, as I said, a roller claw with some Masumi slides going out and in. So what I'll just like start drawing in lines. So for the Masumi slides, I don't know, do something like this. Again, I'm just completely eyeballing this without any intent of placing anywhere. We will figure this out, everything out later on as well, like the dimensions and where to actually place it relative to the dry base. And then so now we actually need to, since it is a roller claw, we will need to create a, um, roller. So I'll just leave that there for now. And then, so the most ideal, like you want to kind of sketch your robot um, out to its very max potential. So what I mean by that is you want to make sure that it can grab a sample kind of very near its extension limit. The reason being is because if it can do that, if it can grab a sample over here, then it can definitely grab a sample over there, right? All you need to do is move your robot back, possibly just like retract the Musumi slides and rotate the mechanism here. But just yeah, make sure you can do its very max. So I actually do have to make a sample now to make my intake. So that was a loud one. So what I'm gonna do is I will take a look back at the manual and find the dimension. I'll probably skip this part. Oh, there it is. 1.5 by 1, so 1.5 by 3.5. Okay. So we'll do 1.5. Holy, that is small. And 3.5. We do not want that long of a sample. Okay, so there's my sample, and right now I'm gonna just place it an inch inside of our extension limit. Raj, does an inch sound fine, or is that kind of a bit too too far of a stretch?
Is it an inch inside the extension? I'm a little bit oh, like the sample position.
Yeah, like where the sample is.
I think that's fine. Yeah, those are good.
All right, so we'll stick with that. And now what I'll do is I'll just create some temporary dimensions between the Misumi slide and the outtake wheel. So I'll do maybe an inch over there, maybe even half an inch. No, not 12 inches, half an inch. And I'm just gonna, since this point marks the very end of the Misumi slide, what I'll do is I'll maybe place the wheel just to make sure I have enough material to work with. I'll place the wheel. Oh, it's not making the correct dimension that I want it to. So here, I'll actually make this not a construction line, and what I'll do is I will do something like this and like that. So there you go. Okay. And now I'm gonna place a dimension here where it's 1/2. So the reason why I did this is because if you notice when I tried to dimension these two dots, it made them, like if you look at where my mouse is, if you look at this area of the line of the Misumi slide representation here, you'll see that the white line of the dimension is not perfectly perpendicular to that line, and I want my dimension to always be perpendicular to that line. So that's why I created a construction line going down here that's perpendicular, and another one going out to the right that's perpendicular to this one. So this line is perfectly parallel with this line, and then I just dimension this to be a half inch. Okay, so I also probably, oh, that is way too much. I also probably want my Misumi slide to start, I don't know, for now I'll dimension it to be 3 inches over there, and I don't know, 5 inches up here. And then I will make my wheel, if we go onto Go Builder, and then go into Wheels and Tires, and then, not the hogback wheel. Raj, which wheels did you guys use for your intake last year?
We use the gecko wheels, the small ones.
48.
Smallest, yep.
Okay, so we'll just make a 48. We'll put a 48 gecko wheel on there. And it's a 48-inch diameter, so what I'll do is I'll just dimension this diameter to be 48 millimeters. And I gotta delete, I dimensioned it twice. Okay, so now we have a very, very basic kind of thing going on with the Masumi slides. And now here is the important part. So you kind of have to figure out in your layout sketch the compression of the sample. So compression is very, very important with first in general, right? With FTC, with FRC, and I'm sure even in FLL. Um, there are, I mean, it's a pretty simple rule. There's a like one kind of very important rule in when doing compression. If you have a hard game piece like the sample, you want a wheel that has that is a soft compression. So, um, because then it can squeeze really easily. And then vice versa, if you have a really soft game piece, kind of maybe like even the cone from two-ish years ago, I think, 3-ish years ago, then you want to have a hard intake wheel. Um, that's the main rule there. You don't want to have a soft intake wheel and a soft game piece. That's just gonna um, mess up your compression. So the way you find out uh, the way you find your compression is honestly just prototyping. Like maybe make a rod and then put some wheels onto there for different distances and see how the game piece interacts with your wheels. Okay, so the plan here is for the sample to get wedged in between this wheel and probably something in between the Masumi slide as well. Um, Raj, do you have any recommendations for that?
Yeah, I think that should be fine.
Okay, so we'll do a plate, and to make sure that my sample fits in, I have to have at least maybe like 1.5 inches of clearance. And then what I'll do is, let's see. So 1.5 is probably, honestly, way too much. Since this is just gonna make the sample perfectly fit inside of this area over here between the Masumi slide and the intake wheel. Um, I want the sample to actually be pressing against the intake wheel to make sure it has like a strong grip. So what I'll do is honestly I'll maybe put like a 1/4 inch of compression. This means that I want this distance to be maybe 1.25, 1.2, 1, holy, 1.1.25 inches. All right. Now, uh, right now we have to layout sketch how the intake will be, of course, intaking the sample. So, of course, you don't want your wheel to be rubbing against the ground. That will be pretty bad. So I will add maybe a 1/4 inch of clearance. A 1/4 inch is always a great place to start whenever you're thinking about clearance between two parts. It's honestly a standard at this point, and it usually works. Okay. And now when I'm intaking, of course this my intake wheel will be tangent to this line, right? Because it'll be touching it, and hopefully it gets in there. So what I can do actually is I can make this even less of a um, less of a distance between the ground. And so what I'm hoping will happen is the sample will go climb kind of on top of the wheel and then wedge itself in between the Masumi slide and the intake wheel. So honestly, this intake probably won't work, but for the sake of this video, we'll roll with it, just to see how layout sketching works and how you should plan everything out. Okay. Um, Also, the placement point for the Masumi slide, I did just kind of go with my gut. But you will have to think about it and you will have to talk about it to figure out the most optimal spot to mount it. All right. Now we do want to make this point rotatable, so we do want to have the whole Musumi slide rotatable. So what we'll do is we will kind of show its rotation trajectory with a construction line, as we did a couple of videos ago when we were making that little, I think, phone stand. Yeah. So the furthermost point of this Misumi slide assembly and intake assembly is this point right here that is showing when I hover over it on the intake wheel. So I'll just press that, and now it shows the trajectory of my intake. All right. Now notice, like, this is again very simple. I don't even have any parts modeled out over here that will hold it up. You can honestly probably figure that out later on, maybe even in the intake document itself. But yeah. Okay. Raj, do you have any questions so far?
No questions so far.
And then another thing I did just notice is we're cutting it very close to the extension limit of the the extension limit. But what you guys will probably have to do is you'll have to retract the Misumi slide and then rotate it around. All right. Cool. Let's look at the Misumi slide just to make sure that everything works out. You want to make sure that your distances for the Misumi slide are actually reachable by it, right? So 24.797, I need to make sure that there is a Misumi slide that can reach 24.797 inches in extension. So this one, 180 millimeters. Okay, how much is that in? I need that in American, but man, I lost my document. We'll go here. Okay, so I'm just gonna check that 24 point whatever inches maybe is. I don't think it is. It's probably way too long. Yeah. Raj, are there any longer Misumi slides?
Um, what do you mean by? I mean, these you can get them like to stack together. Like that's the
Oh, I
idea.
see. Oh. Oh,
Yeah.
okay. I see. All right. Um, cool. And then you guys might not even need this whole stroke length because you might just like intake it somewhere inside of here anyway. Because there's samples all inside of the submersible anyway. So yeah. Okay. So very simple side layout sketch. It should it should honestly be more. You guys probably will have a lot more complexity in your layout sketch for the intake later on in the season. Um, so yeah, but I'll be there to help you guys out. So it should be fine. Okay. Now we're just gonna go on to actually making it 3D. So the Misumi slide will honestly just make it a square in the side layout sketch. So something like this. Yep, and then make sure these two lines are parallel to each other. Cool. And then we have to find out how thick they are, right? So Raj did say we can stack them. So you will have to figure out the specific spots of where you're going to stack it. So in reality, what you probably will have is something kind of like this, where this is one Misumi slide going out here. Raj, will you be stacking them? I'm assuming side to side, right? Not on top. Like,
In this case, it makes sense on. I mean, yeah, you can do side to side. It'll probably be easier for this case,
okay,
and most likely we'll be doing that.
all right.
Yeah.
So it will be side to side. So I lied. You'll just have to create a little rectangle to present the um, side sketch of the intake. Okay. Now, going back to we need drawings and specifications. So from the side view, looks like it's about which one? SAR 230. It doesn't have SAR 230 here, but that's we'll just take a random one. Um, let's see. I need so it says 15 over here. I'm assuming that's millimeters. I think that should make sense because they use millimeters for everything else. 15 inches would be a pretty big Masumi slide anyway. So I'm gonna make this 15 millimeters. Cool. All right. Um, that looks pretty good to me. Um, and then so we'll do yeah. Okay, so we'll do that. And then now what we can actually do is we could make another sketch where we have the sample just in its optimal intake position. So you generally want to CAD your game piece from touch it to own it, right? So here's my sample. I will just use equal constraints to get all the dimensions from the other sample that I made in the other sketch. And now we did say 1/4 inch of compression. So in an ideal world, it will probably be, well, it'll be a 1/4 inch of compression on the wheel because of course it probably can't go through metal. And then if it can go through metal, then there's something wrong with your Masumi slide. All right. And honestly, I would probably have it intaked maybe about halfway through. So what I'll do is, again, this is where construction lines come to play a lot. So instead of just dimensioning it from this point to this line and then making it, since it's 3.5, I could just make it 3.5 by 2. But what I could do instead is do a couple of construction lines and find the middle of this circle somewhere. Where is the middle of the circle? Okay, for now I'll do this. So find the midpoint of U, find the center point of the circle, and then make this construction line parallel to this construction line. Then there you go. Now it's in the middle, and now it's going to be moving with your, like if you change the length of your Masumi slide, then this whole assembly will also, like this whole sketch will also change in length. So that's why. That's why you want to use construction lines instead of dimensions. And geometric constraints. All right. Cool. So I'm gonna make this ideal. So own it, right? And then what I'll do with this one is I'll actually just name it to intake layout. I'll name it to touch it. And then I'm just gonna make another folder called intake where I will just place these two sketches in, and I'll move the rollback bar up below own it. Okay, so that so far is the intake for us. Now we have to make the sketch from the top view. So what I'll do this time actually is instead of making a plane in the middle of the Masumi slide as we did all this times, I will make it on the bottom since it will be coming to contact with the sample. So I will make a plane like that. I will call this bottom Masumi. Cool. And then what I'll do is going back to my touch it doc, I'm gonna make a construction line. Oh, we actually already have a construction line there. Okay, cool. And then what I'll do is I'll make another plane on that construction line, kind of like this. That is 90 degrees, so it's facing upwards, parallel to this plane as well. And call it intake wheel. All right. Now we just, well, now it's actually going to be a bit more different. We have to CAD the, as Raj said, you guys will be probably stacking them Masumi slides, so we will have to very basically CAD that. All right, and I wonder why it's. Did I put it on the wrong plane? I did put it on the wrong plane. If you go back to your touch it dock and instead of putting it on left DB, make sure it's on the right plane. And yes, you can very easily switch sketch planes like that, and it'll preserve all the sketches. So pretty cool. Okay, there you go. That makes a lot more sense. Okay. So back to sketch one, bottom Misumi, and I'll just name this top Misumi. Okay. Now, if we go into the Misumi drawings and specifications, from the top view, we'll be looking at, let's see, so it's 180 millimeters per Misumi slide. So let's figure out how many we need first. So we can do this with a bit of simple math, honestly. And I mean, instead of doing that, what I'll do is I'll just use construction lines to quickly represent the Misumi slides that I'll need. So since this is on the same plane as this line over here, I can use the points on it as we've talked about previously. So for now, I'll just make 2 lines real quick, and each line represents a Misumi slide. So this line over here, I'll make 180 millimeters. This line over here, I'll make 180 millimeters. So we are short, and then this line over here. And if you guys notice, I am making a mistake here. I could easily just equal them instead of dimensioning the same thing. And then we have a bit of distance over here that we can cover. Now, what you could have done is as well as just not worry about this distance at all and just intake the samples closer to the robot, and then you'll save some weight here. Which is actually, yeah, let's just do that actually. So, and it'll show you guys how changeable like your layout sketches actually really are. So if we go into the touch it, own it dock, what we can do is we can just easily change the distance we place the sample inside of the frame perimeter. So if we change it to 5, for example, everything in my other docks should change as well. So going into the top Misumi, you'll see that now we have 3 Misumi slides very easily. Like they can very easily reach the sample. All right, Raj, any questions before?
Nope, no questions.
Okay. All right. Now, Raj, I'm assuming you're gonna have is it 1 set of Misumi slide or is it 2 sets? Like you'll have 2 on either side.
2 on either side.
Okay, cool. So I'm also just gonna quickly eyeball that. They will most likely be from the top down view, Raj, right? Like, so for example, if you stare straight at the intake from the front, you'll see this, right? Like the front of the Misumi slide.
Yeah, yeah.
Okay, cool. So the width of the Misumi slides is 5.8 millimeters in total. So I'm just gonna make it very basically, 5.8 millimeters. And then what I'll do is I'll actually use a lot more construction lines to constrain my Misumi slides, just to not model the length again. So this way I don't have to use the 180 millimeter dimension again. I can just very easily use these lines over here. Okay, and then I just have to do that a couple more times. So I can just do this. And then for this Misumi slide, actually, we don't need its full stroke. So what we can do instead is, instead of making another corner rectangle that is horizontal with the very end point of the Misumi slide, I'm just gonna make it as long as it needs to be, which is this point slightly below the max extension of the Misumi slide right there. So I'll just drag my mouse out and there goes the horizontal constraint with the orange dotted lines. Then I'll just click and there you go. We have one side of the Misumi slides. Raj, I don't feel like I'm doing this correctly. You're gonna have to. They're gonna be overlapping a little bit, correct? Okay, so here are the three Masumi slides that we made, and now we have to decide how wide we want them to be from the center of the bot. Um, Honestly, I'm pretty comfortable with 3.5 inches. The um, sample itself is 3.5 inch or 1.5 inch wide, so honestly, 3.5 inches might be too much. I might do 2 inches instead. Um, Maybe even less. So I'll do 1.5. So my thinking here is from the top, the sample is 1.5 inches in width. So if I mirror this, and I am planning to mirror it, if I mirror this set of Masumi slides over to the other side, the total distance in between will be 3 inches, which leaves us with about 1.5 inches of play, which I think should be good. We could try 2 inches, which leaves us with half. We'll do 1.25, split the difference. Okay, cool. And now I'll just mirror this whole thing over like, I have to go into a normal plane. I will select everything here, and then I'm gonna click the mirror. Nope, I did it again, wrong again. Select mirror. I click on the mirror line that I want, and then I just select the right side of Masumi slides, and there you go. We got ourselves a nice little Masumi slide assembly going. All right, and then now the last thing we have to do is create the wheels. Or the intake wheels, yeah. So for the intake wheels, I will just make them kind of. I'll honestly just make them a bit less than the distance between the Masumi slides. So I'll do this wheels top. Cool. And now I can use the center point of the circle, so right there, and then make a center point rectangle, kind of like that. Dimension the top of it, or coincident it with the, never mind, that doesn't work. What I'll do is actually I'll project this circle, so that creates a line since it is in top view. Then I'll coincident the top point of my rectangle to the top point of this construction line. And then we're gonna see how wide these wheels are. So 16 millimeters in width. Let's do 16 millimeters times 4. So that is honestly just cutting it. Oof, that is too much. So we'll do 16 millimeters times 3. So 3 gecko wheels in between there. And 16 millimeters, 2 inches is, alright, sorry, 16 times 4 millimeters, 2 inches is 2.51 inches, which gives us about 1 inch of play with the sample itself. Okay, cool. So that is the most basic, simple kind of layout sketch of an intake that you can do. Yours again will probably be a lot more difficult, and as you can see, it still is very kind of very simple, no motors at all, just kind of structure and like representing it with again rectangles, circles, lines, and construction lines, and that's it. So yeah, Raj, any questions?
No, nothing's.
All right, cool.
No questions.
All right, so then we'll see you guys in the next video where we will try to 3Dify this.